The National Electrical Code, or NEC, does not specify a maximum distance between the point of entry of the service entrance conductors and the main service panel. However, some local electrical codes may impose such a requirement. The specific distance may vary by jurisdiction. The Pennsylvania Electrical Code does not contain a specific maximum distance requirement for the location of the main service panel from the point of entry of the service entrance conductors. The National Electrical Estimator, also known as the Blue Book, recommends a maximum distance of 10 feet. The NEC Handbook suggests that the ideal distance is as close as possible to minimize the length of the service entrance conductors. The distance requirement, if any, typically refers to the total length of the service entrance conductors from the point of entry to the main service panel. The NEC does require that the service entrance conductors be as short as possible to minimize voltage drop. Other factors that may affect the location of the main service panel include accessibility for maintenance and space constraints. Firstly, it is crucial to understand the role of service entrance conductors. These conductors are the lifeline of electrical power to any building, connecting the utilities grid to the building's electrical system. Their primary function is to carry electrical current safely and efficiently from the service drop or lateral to the main service panel inside the building. Secondly, minimizing the length of service entrance conductors is essential for several reasons. A shorter conductor length reduces voltage drop, which ensures that electrical devices receive the proper voltage for optimal performance. It also minimizes the risk of power loss due to resistance in the conductors. Thirdly, local electrical codes often have specific requirements regarding the installation of service entrance conductors. These requirements may include minimum wire gauge, conduit type, and burial depth. It is essential to comply with these local codes to ensure the safety and legality of the electrical installation. The NEC provides comprehensive guidelines for electrical installations, but it does not specify a maximum distance between the service entrance point and the main service panel. This is because the optimal distance can vary depending on factors such as building size, layout, and local code requirements. The NEC Handbook suggests that the ideal distance is as close as possible to minimize conductor length and voltage drop. However, practical considerations such as accessibility and space constraints may influence the final placement of the main service panel. The National Electrical Estimator, also known as the Blue Book, is a widely used reference for electrical contractors. It provides cost estimates for various electrical projects, including service entrance installations. The Blue Book recommends a maximum distance of 10 feet between the service entrance point and the main service panel. This recommendation is based on industry best practices and aims to ensure efficient and safe electrical installations. When determining the location of the main service panel, several factors must be considered. One crucial factor is accessibility for maintenance. The main service panel should be easily accessible for routine inspections, repairs, and upgrades. It should not be located in a confined or obstructed space, as this can hinder maintenance efforts. Another factor is space constraints. The main service panel requires adequate space for installation and operation. The available space may limit the placement options, especially in existing buildings. It is essential to carefully assess the space requirements before selecting a location for the main service panel. Voltage drop is a significant concern in electrical installations. It refers to the reduction in voltage that occurs as electrical current flows through a conductor. Excessive voltage drop can lead to dimming lights, malfunctioning equipment, and overheating conductors. To minimize voltage drop, the NEC specifies minimum conductor sizes based on the load and distance. Using larger conductors can reduce voltage drop, but it also increases the cost of the installation. The length of the service entrance conductors directly impacts voltage drop. Shorter conductors result in less voltage drop, while longer conductors result in more voltage drop. Therefore, minimizing the distance between the service entrance point and the main service panel is crucial for maintaining proper voltage levels. If local codes impose a maximum distance requirement, it is essential to comply with it. These requirements are put in place to ensure the safety and reliability of electrical installations. Local electrical inspectors are responsible for enforcing these codes and can provide guidance on specific requirements. The total length of the service entrance conductors is the distance that matters most. This includes the horizontal and vertical runs of the conductors from the service entrance point to the main service panel. The total length determines the overall resistance of the conductors and the amount of voltage drop that will occur. To obtain the most accurate information, it is advisable to consult with a local electrical inspector. They can provide specific regulations applicable to the jurisdiction. Consulting with a qualified electrician is also recommended. An electrician can assess the specific requirements of the installation and ensure that it complies with all applicable codes and regulations. The NEC requires that service entrance conductors be as short as possible to minimize voltage drop. This requirement is based on the principle that shorter conductors offer less resistance to electrical current flow. By minimizing the length of the conductors, the voltage drop is reduced, ensuring that electrical devices receive the proper voltage for optimal performance. When determining the location of the main service panel, consider the accessibility for maintenance. The panel should be easily accessible for routine inspections, repairs, and upgrades. Avoid placing the panel in a confined or obstructed space, as this can hinder maintenance efforts and pose safety hazards. Space constraints can also influence the placement of the main service panel. Ensure that there is adequate space for the panel itself, as well as for working around it during maintenance and repairs. Consider the dimensions of the panel and the clearances required by the NEC. Other factors that may affect the location of the main service panel include the proximity to other electrical equipment, the presence of flammable materials, and the potential for physical damage. Consider all of these factors when selecting a location for the panel. Before starting any electrical work, obtain the necessary permits from the local building department. Permits ensure that the installation is inspected and complies with all applicable codes and regulations. Failure to obtain permits can result in fines and delays. When installing service entrance conductors, follow the manufacturer's instructions and the requirements of the NEC. Use the correct type and size of conductors and ensure that all connections are properly made and tightened. Improperly installed conductors can pose safety hazards and lead to equipment failure. Regularly inspect the service entrance conductors and the main service panel for any signs of damage or deterioration. Look for cracked insulation, loose connections, and corrosion. If any problems are detected, have them repaired promptly by a qualified electrician. Service entrance conductors and the main service panel are critical components of the electrical system. Proper installation and maintenance are essential for ensuring the safety and reliability of the electrical supply. Failure to follow these guidelines can result in electrical hazards, equipment failure, and property damage. To summarize, firstly, the National Electrical Code does not specify a maximum distance between the point of entry of the service entrance conductors and the main service panel. Secondly, some local electrical codes may impose such a requirement, but the specific distance may vary by jurisdiction. Thirdly, the Pennsylvania Electrical Code does not contain a specific maximum distance requirement for the location of the main service panel from the point of entry of the service entrance conductors. Fourthly, the National Electrical Estimator recommends a maximum distance of 10 feet. Fifthly, the NEC handbook suggests that the ideal distance is as close as possible to minimize the length of the service entrance conductors. Sixthly, the distance requirement, if any, typically refers to the total length of the service entrance conductors from the point of entry to the main service panel. Seventhly, the NEC does require that the service entrance conductors be as short as possible to minimize voltage drop. Eighthly, other factors that may affect the location of the main service panel include accessibility for maintenance and space constraints. To obtain the most accurate information, consult with a local electrical inspector. The NEC provides guidelines for electrical installations focusing on safety and performance. The code addresses conductor types, sizing, and installation methods to minimize risks. Firstly, conductors must be appropriately sized based on the load they will carry, as detailed in NEC Table 310.15b16. Secondly, proper grounding and bonding are critical for safety, and NEC Articles 250 and 280 provide specific requirements. Thirdly, overcurrent protection devices, such as circuit breakers and fuses, should be selected and installed according to NEC Article 240. Fourthly, wiring methods, including conduit and cable types, must comply with NEC Chapter 3. Fifthly, regular inspections and maintenance are essential for ensuring the continued safe operation of electrical systems. Firstly, understanding voltage drop is critical. It's the decrease in voltage that occurs as electricity travels along a conductor. Secondly, excessive voltage drop can cause lights to dim, motors to run inefficiently, and appliances to malfunction. Thirdly, NEC Section 210.19 AM provides guidelines for limiting voltage drop in branch circuits. Fourthly, calculating voltage drop involves considering the conductor length, current, and resistance. Fifthly, using larger conductors can reduce voltage drop, but it increases material costs. In summary, minimizing the length of the service entrance conductors is a practical approach to ensure efficient power delivery, reduce voltage drop, and comply with the NEC emphasis on safety and performance. Consult with local inspectors and qualified electricians to tailor the installation to the specific conditions and regulatory requirements. Firstly, always prioritize safety when working with electrical systems. Secondly, ensure proper grounding and bonding to prevent electrical shock hazards. Thirdly, use appropriately rated tools and personal protective equipment. Fourthly, never work on live electrical circuits unless absolutely necessary, and always follow lockout/tagout procedures. Fifthly, if unsure about any aspect of the electrical installation, consult with a qualified electrician. Remember that the NEC and local codes are constantly evolving, so staying up to date on the latest requirements is essential. Regular training and education can help electricians maintain their expertise and ensure safe and compliant installations. In conclusion, while the NEC doesn't mandate a specific distance for service entrance conductors, minimizing their length is a best practice for reducing voltage drop and ensuring efficient electrical system performance. Always consult local codes and qualified professionals for precise requirements and safe installations.